Hi everyone, good morning and welcome back to KCS online platform. I hope you all are doing great. And again, we are in the bridge course. In the last class, we are discussing about the motion. We have also discussed about the what exactly distance or what exactly displacement is, and further we have discussed about the difference between the speed and velocity. What exactly speed and what exactly velocity. But we have not discussed if the velocity is changing, what extra or what new concept will come. Suppose a person is standing here and he start running. Okay, so here time equals to 0. So after 2 seconds, he will cover say some 10-meter distance. Okay, so 2 seconds is very less. So let me take 2 minutes. Okay, or 5 seconds something. So 5 seconds. Again after 5 seconds, he will come here. Okay, so after 5 seconds he will come here. Again after 5 seconds he will come here. But distance traveled is what? Again 10 meter only. So again he will come here. Distance traveled is 10 meters. So again time when you look at the time was exactly 5 seconds only. Okay. So now what exactly happening here? If I calculate the velocities in all these cases, since it is in straight line motion. So what is the velocity here? 10 by 5, that is 2 meter per second. What is velocity here? 10 by 5. So again here also 2 meter per second. Here velocity is 10 by 5. Again it is what? 2 meter per second. Then what we are observing here? We are observing his velocity. His velocity is not changing with the time. His velocity is what? His velocity is constant. It is not a variable. Okay. If person is moving with the constant velocity, then velocity we can call it as what? We can call it as uniform velocity. We call it as uniform velocity. If a person is moving with uniform velocity, no problem. You can just define or you can just talk about the velocity. Instead of that one, suppose at time t equals to 0, the person is standing here. Okay. Now after say some 5 seconds, he will come here. So distance traveled is 10 only. But again after 5 seconds, distance traveled is 20. Again after 5 seconds, distance traveled is what? Distance traveled is 30. Okay. Now what is happening in the same interval of time? Distance covered by person is different, or displacement is different. Now if I calculate what is the velocity here, velocity is 10 by 5, that is 2 meter per second. Okay, here velocity is what? 20 by 5, so here it is 4 meter per second. Now here velocity 30 by 5, so what is that? 6 meter per second. Okay, now what is happening? In the same interval of time, 5 second, distance traveled is different. Means velocity in first 5 seconds is different. Velocity after 5 seconds, it will become 4. It will become double. Again for next 5 seconds, velocity is again 6 meter per second. What is happening? Velocity is increasing. Velocity is increasing. Okay. So I can simply write velocity is what? Velocity is increasing. Okay. So now what you can say, if velocity is changing with time, or if velocity is increasing or changing with time, then you can call it as it is a non-uniform velocity. It is the non-uniform velocity. Okay. So if it is a non-uniform velocity, if your velocity is increasing, then what you can say? When you start your bike, so first when you start, its velocity is less, or it is 0. So it will become 10 km per hour, then it will become 20 km per hour, then it will become 30 km per hour, then 50 km per hour. So what you feel? You feel like you are increasing your velocity. Then what you will say? You will say that your bike or some vehicle is accelerating. So when you accelerate means what? You are increasing the velocity or you are changing the velocity. So that what we call it as, acceleration. We call it as acceleration. Then what exactly acceleration is? Acceleration is how much velocity is changing or how velocity is changing with time. That is change in velocity divided by time is called as what? Is called as acceleration. Okay, so now if I can write something else also. So what is change in acceleration here? The final velocity is what? 30. Okay, minus initial velocity is what? Here velocity is what? Here velocity is 0. So 30 minus 0. Total time taken 5 seconds, 5 seconds, 5 seconds. That means 30 seconds. Okay. So what is going to be your acceleration? Acceleration is going to be 1. For velocity we have unit meter per second. Again time is there, 1 more second. That means meter per second square. Okay. Then can I write some other formula for acceleration? What I can write is acceleration is equals to final velocity minus initial velocity, initial velocity divided by total time taken to go from 0 to 30 or to go from 10 to 30. What will be the it is starting from here, it is 0. You should say velocity here is 0. Okay, so at this point it will become 10, at this point it will become 20, at this point it will become 30. Okay, so this is how we can calculate the acceleration. Okay, or you can say you will start only from 10 meter per second. Here your velocity is 10 meter per second, and now here your velocity will become say 50 meter per second. So time taken is what? Time taken is 10 seconds. Okay, so what is your final velocity? Final velocity is say 50. Okay, so then what is initial velocity? Initial velocity is say 10. So acceleration is what? Final velocity minus initial velocity divided by time. Time taken is what? 10 seconds. So 50 minus 10, 40 divided by 10. So acceleration is going to be what? Acceleration is going to be 4 meter per second. Okay, so 4 meter per second square. Okay, so this is how we can get the acceleration. Suppose your velocity is decreasing. Your vehicle is already going. Suppose your vehicle is already going with say some 50 km per hour, and here your velocity will become, say 10 meter per second. Here what is happening? Your velocity is what? Your velocity is decreasing. Your velocity is decreasing means now you cannot say it is accelerating. What you will say? It is de-accelerating, or you can say it is retarding. You can say it is retarding, or it is called as retardation, or you can also call it as de-acceleration. Okay, so this is what, when velocity is increasing or when velocity is changing, one more term will come. That is what we call it as acceleration. So after acceleration, one more important term is which is required is that is what we call it as momentum. Okay, so we call it as momentum. So what is that momentum? What exactly momentum is? Okay, so suppose you are having a small mass here, say of some 5 kg. Okay, so some 5 kg. You will apply say some force F. So due to that one, so it may travel say some 10 meter per 10 meter. So with velocity of say 10 meter per second. Okay. So instead of that one, if mass is very big, 10 kg. So when you apply the same force F, when you apply this little force on the small ball, it will travel for longer time. If you apply the same force on a bigger ball, then what will happen? It will travel. It will go with a little less speed. Okay. So what will happen? Now it won't travel with 10 meter per second. It will travel say only 5 meter per second. Okay. So then amount of distance, when something is of small size, you can throw it for longer distance. If something is of bigger size, you cannot throw it for longer distance. So it may travel say some 2 meter. Okay. So this is what we can say amount of motion. This is what say amount of motion. Amount of motion. So amount of motion depends on what? Here. So mass is less. So that is why it is traveling it is traveling what? With a more velocity. Here mass is more. It is traveling with what? It is traveling with the less velocity. That means the amount of motion depends on the mass, and also it depends on what? It also depends on velocity. The amount of motion depends on mass and depends on velocity. So your amount of motion is proportional to what? It is proportional to mass and velocity. Mass and velocity. Okay. So this product of mass and velocity, we call it as momentum. Okay. So you can denote it by P equals to M into V. But what exactly the physical meaning of momentum? What do you mean by that M into V? That is what we can say amount of motion. So this momentum will give you what? It will give you amount of motion. Okay. So that is what momentum P equals to M into V. M is kg and V is what? V is meter per second. Okay. So this is what you can write as kg meter per second. Okay. So momentum is one of the important tool in explaining the Newton's laws. So regarding motion, how body will move, or how much it will move, how much force is required. Those all things you must have studied in your 9th class or 10th, maybe probably in 9th class. So laws of motion, it will follow some laws. Okay. So you are going to be study about that in detail in your first year, and you have little gone through those laws. Now what I will do, I will just try to take a bridge between those two. Okay. I will not go into deep complete explanation, and I will just take whatever you have studied and we will just highlight the what Newton's laws. Okay. So now that is what we can call it as laws of motion. Laws of motion. So it is given by what? It is given by Mr. Newton. Okay. So that is what we can say. It is given by Newton. So it will assume that he is Newton. Okay. So Newton's laws of motion. Okay. So directly we will go with the first law. So first law. What first law suggests is what it suggests. It suggests that unless an external force is applied, unless an external force is applied on body, it continues to be in the state of rest or motion. Okay. you have this definition, or it may be a little different. Okay, unless an external force is applied, suppose I am having the duster over here, unless I apply the force on this one, it will not move, or something is already moving. Unless you stop it, unless you apply the force and stop it, it continues to be what? It continues to be in the state of motion. Suppose a body is kept here, okay. Now nobody is coming here, so no disturbance. That means it is going to be at rest only. It is going to be at rest only, because no force is acting here. Nobody is acting the force. Okay. Similarly, if suppose somebody come and push it on this direction, if force is applied in this direction, what will happen? It will move. Okay. So when it starts moving, when external force is applied, until external force is applied, the body is at what? Body is at rest, and it is going to be rest only until you apply the force. Okay. Or suppose a bullet is moving with a high speed. Okay. So it continues to be in the motion unless you bring the some wooden box or something in between. Okay. If no friction is there, suppose you have the vehicle. Suppose you have the vehicle. If it is moving some velocity, so what will happen? It keep on moving with that velocity only till then you apply the brake. When you apply the brake, what will happen? Its velocity decreases. It means there is a change in the state of its motion. Unless you apply the force, what will happen? Body will not change its state of rest or motion. Okay. So this is what. So this. That is what inability, we can call it as inability of the body. Body will not change its state of rest or motion until then external force is applied. Means the body is unable, or it has inability. So what we can say, inability of body to change its state, of rest or motion. Inability of the body is not able to change itself. This inability we call it as what? We call it as inertia. Very important term. This is what we call it as the inertia. Inertia is what? Inability of the body to change its state of rest or motion itself. If you apply the force, if it's changed, no problem. Okay. So if without applying the force, it is not able for the body do not have ability to change its state of rest. That is what we call, that inability is called as what? Inertia. So that is why first law is also called as what? Law of inertia. It is also called as law of inertia. Okay. Now if we see at some examples over here. Now if I see some examples here. Suppose you are having the mat. Okay. So usually put it at the door or something, and that mat is got very dusty. Okay. So what you will do? You will take the mat, and what is there? Dust particles are there. So many dust particles are there. Now to remove that dust particle, what you will do? You will beat it with a stick. Okay. So you will take one stick and you will beat that mat with a stick. So actually what you have done, you just move the mat from here to here. Okay. Your mat is moving from here to here. So when mat move from here to here, these dust particles are going to be there in the state of rest, because you are not applying the force on what? You are not applying the force on dust particles. You are applying the force on mat. So mat will move. Then what about dust particle? They don't want to change their state of rest because it is their inability. Unless you apply force on them, they will not change. You are applying force on mat. So mat will move and they remain there only. When when mat go on this side, so these dust particles they will just fall down. because no support to sit there. Okay, so this is what the example of what the first law. Okay, or suppose second thing, you have a tree. Okay, so here some flowers or leaves or whatever things are there. Okay, so say some flowers are there. Okay, so here some flowers, here some flowers. Okay, so what will happen? Suppose if it is a big tree, so if you want to take those all flowers or leaves, whatever, what you will do? You will not go to the top of the tree and just take it down, take it out. Not, you won't do like that. What you will do? You will just hold this branch and you will shake it. You will shake the what? So you will go here and you will shake the one branch of that tree. So now what will happen? All these the flowers fall down. Why? You are applying force on what? Branch. So what will happen? Branch will move here and here. Branch is moving. But what about the flowers? Flowers want to be there in the state of rest or motion. So flowers are going to be what? In state of rest only. So when the branch move on that side, these flowers are going to be there. So what will happen? They will fall. Okay, or when the rain comes, so when you just shake the any branch of tree, what will happen? The water droplets will fall down because they want to be in the state of their rest. Okay, so similarly, like that, suppose you are traveling in the bus and you are sitting in this last seat. Okay, so you are sitting here. So what will happen? Suppose this driver suddenly apply the brake. Since bus is moving, bus is in motion. Suddenly, if brake is applied, okay. So suddenly, if brake is applied, what will happen? Your body is in motion. When suddenly brake is applied, your bus will come to what? Your bus will come to rest. But still, you are in motion. You don't want to change your state of motion. If somebody applied force on you, you will change. But driver is applying force on bus will stop. What about you? You want to be there in the continuous state of motion. So what will happen? Your body will move forward. Your body will move forward. When suddenly brake is applied, your body is in motion. So suddenly what will happen? You will feel like falling down. Okay. So this is also what the example of first law. Okay. Similarly, if you want one more example, suppose your friend is driving the bike. Okay, and he is sitting here. So your friend is driving the bike. So behind him, you are also sitting here. Okay, so you are also sitting. Your friend is driving the bike, and you are also sitting. Obviously, you are singing the song and you are going with say some 60 km/h. Okay. Suddenly, what will happen? He is not wearing the helmet, so suddenly you will see the policeman. What will happen? He will apply the brake all of a sudden. You are moving with 60 km/h and suddenly you will apply the brake. Or if you are speed is say some 100 km/h, you are going with very high speed, and suddenly your friend will apply the brake. When suddenly apply the brake, your bike going to be stopped because he is applying force on bike. What about you? You are in 100 km/h speed and you want to be there in 100 km/h. Okay, so what will happen? Suddenly when you apply the brake, you will come and fall down here. Okay. So what will happen? Everything will get over at that moment because you are not wearing helmet. Okay. So that is a different thing. Why you are falling forward? Because you want to be in the state of your motion. So like that, so many examples you can see when you are getting down from the moving bus. So what you have to do? You have to run for little 4-5 steps because your body is still in motion. Suddenly it will not come to the rest. Okay. So these are the few examples of first law of motion. We will go with second law. Okay, second law of motion. Okay, so what it suggests is when the force applied on the body, what will happen? Acceleration will take place. Okay, how much acceleration you want means how much change in speed you want. It depends on what how much force you are applying. How much force you apply, that much acceleration you will get. Means how much you are increasing the speed of your vehicle, means what you are applying some force, that is you are accelerating. So suppose you are having a body. Okay, so you are having a body here, say of mass say some m. Okay, so if you want to give the acceleration, you want to here velocity say 10 meter per second. Okay, so you want to increase velocity suddenly to say some 60 meter per second. Okay, so for that in a very short time you want to do that one, you will take only 10 seconds for that one. Okay, so what is the acceleration? What is the acceleration is say 60 minus 10, that is 50 divided by 10, that is 5 meter per second square. Okay, to give the acceleration of 5 meter per second, you have to apply some force. Okay, so if you want to give suppose to give the 5 meter per second per acceleration, you will apply some force say 10 newton. To give 10 meter per second acceleration, what you have to do? You have to give more force. Okay, if you want more acceleration, means you have to apply more force. That means your force is what? Directly proportional to acceleration. Now second thing is you have the mass of say 5 kg. Okay, to move it to 10 meter, you will apply say some 10 newton of force. You will apply some 10 newton of force. If instead of that one, suppose 10 kg is there. Okay, to move this 10 kg to 10 meter, so you have to apply force more than 10 newton. Here 5 kg is there. What you will do? You can just move it. If 10 kg is there, you have to apply what? More force. Okay, that means you have to apply say 20 newton of force. Okay, that means if mass is more, force applied is also what? More. Okay, so here also, that means more mass means what? Means more force you have to apply. More mass means you have to apply more force. Okay, if mass is more, the force applied should be more. If you want more acceleration, you have to apply the more force. That means force is directly proportional to mass and acceleration. That is why we will write it as F equals to ma. Okay, so this is what the basic understanding of what exactly the Newton's second law, or what exactly force is, mass into acceleration. But what actually second law is saying? Second law is saying the force applied is directly proportional to rate of change of momentum. You must have heard this definition. So what is the definition of second law? The applied force is always directly proportional to rate of change of momentum. Momentum is what? It is the amount of motion. Okay, if applied force is more, there is a more amount of what motion you will get. If applied force is less, you will get the less amount of motion. That is what? Rate of change of momentum is proportional to applied force. Suppose you are having the say bullet. Okay. Suppose bullet is coming with a high speed. So what will happen if suddenly in between you, if your hand comes for something, you hold your hand. What will happen? Bullet will penetrate because it is moving with a very high speed. When it is moving with a very high speed, it will spend a little time. Okay, so here what? Velocity is more, but amount of time spent is what? Very small. Instead of that one, so what will happen? Effect is more. That means force applied on your hand is going to be more, so you will get hurt. Instead of that one, if a person is playing a cricket and he get the ball to hold it catch, so what he will do, he will take it for a longer distance. Before holding the ball, he will take it for longer distance. Why? It is coming with the speed. If you suddenly hold it, it will hurt you more. If you take it for longer time, what will happen? The change in momentum is going to be reduced. Means for a longer time it is going to be in your hand. If it is there for shorter time, effect is more. If it is going to be for a longer time, here to change this much distance, to change this much amount of motion, time taken is very less, 0.01 seconds. Say. Here to change this much of amount of motion, say it will take say some 10 seconds. Okay. That means if something is taking for a longer time, what will happen? The effect is less, means force is less. If momentum is changing for a short interval of time, what will happen? Effect is more. That will hurt you more. That means your force is proportional to what? Change in momentum, and your force is inversely proportional to, or you can say it is rate of change of momentum. That is momentum divided by time. Short time, more momentum, more hurt. Long time, less or more momentum, what will help? It will hurt you less. Okay. So that is why we can write it as force is proportional. You can also write it as dp by dt. Means small change in momentum in a small interval of time. Okay. Or simply you can write this is equals to change in momentum means what? Mass into V final minus V initial divided by time. Okay, so what is this mass? What is V final minus V initial? This I will combine, V final minus V initial divided by time. V final minus V initial divided by time is what? It is nothing but acceleration. So again you are going to get the same equation, F equals to me. Okay. So you are going to study about this in detail, what exactly second law is. But as of now, you just remember second law is talking all about F equals to me, and examples are those only. It will take a long time when you are catching the ball or something. So the high speed moving bullet will hurt you more because it is acting for a short interval of time. Okay. So next is third law. Again, this so you all know very well. Very simple. If you slap somebody, they will also slap you. Okay. So like that. Suppose a body is applying the force F on that one. That body will also apply the force F, but it is opposite. Okay. If it apply the force F12, this force is F21. So these two forces are what? These two forces are equal and opposite. So what I can write, F12 is equals to F21. Okay. How much force this applied on this one? That much same amount of force this will apply on this one. So that is what we call it as for every action. For every action, there is equivalent, there is equal and opposite reaction. There is equal and opposite reaction. Okay, so this is what we can call it as the Newton's third law. For every action there is a equal and opposite reaction. Okay, so suppose what we can, the general example is, suppose bullet fires the gun fires the bullet. So bullet will move in forward direction because F force is applied. Same amount of F is applied on this gun also, so that is why gun will move in opposite direction. Then you may ask me why it will not move that much speed and that much long distance, because its mass is what? Its mass is more. Okay. So here we can say conservation of momentum takes place. Based on that you can solve the problems also. So as of now you can just remember for every action there is a equal and opposite reaction. Okay. Suppose you have the two bodies, so there is a gravitational force between these two. Okay. So this gravitational force between these two is what? These two is going to be equal and opposite. Okay. So this is what? F1g is equal to F2Z. So but it is what, it is opposite, so we will take the negative side. So here also we have to take negative side. Okay, so if you want to see that one, suppose I am having the I am having two what weighing machines over here. So what I will do, I will connect it one by one. So what I will do, I will apply the force on this one. Okay, so if I apply the force on this one, so when I take, now it is showing 0. Okay, so if I apply force on this one, so here how much it is showing, 350 sorry, it is showing 3.5 Newton of force on this side. On this side also it is showing what, 3.5 Newton of force. That means it is equal and opposite. How much force this is applying on that one, same amount of force this is also applying on this one. Okay, so that is what Newton's third law. You will study in detail what is first law, second law and third law in your first year chapters after your motion chapter. So there we will discuss in detail. So again, take care, bye. We will meet in the